Good afternoon, everyone, and thank you for attending our Lightning Protection System Design Fundamentals webinar. My name is Ed McMahon, sales engineer here at Liberty Electric Products. Before we get started, just wanted to let you all know that you're going to be muted during the presentation. So if you have any questions as we move along, go ahead and enter them into the questions panel located in the webinar control, and we'll be sure to reply back to you by email, as we're not going to be taking live Q&A today. Also, we're going to be recording this webinar, and we'll be posting both the recording and the slide deck on our website for you, should you want to review it or send it to somebody else. So our presenter today is Bill Kramer, who's the Eastern Regional Sales Manager for Harger, who's one of the industry leaders in lightning protection and grounding products. With over 140,000 square feet of manufacturing space and 2 U.S. plants, Harger has quickly become one of the largest suppliers of innovative and installer-friendly lightning protection components. So without further ado, I'll pass it over to Bill.
Okay, thank you, Ed, and thank you to everybody that's taken time out of their day to be here. And we'll go through this presentation, and hopefully it'll be beneficial. You'll get something out of it. And like Ed said, we'll answer any questions that you have that you can send those in. So lightning protection system design. Right here, we're just saying that this does count for continuing education credit. There's the disclaimer there for you. Copyright, laws, statement. What the purpose is and the learning objectives are today, there's 7 topics that we're going to cover. At the end of the presentation, hopefully you'll be able to define lightning and lightning protection, compare the applicable standards for lightning protection, describe lightning protection design basics, and understand the inspection and the maintenance of these systems. The presentation will be based off of NFPA 780, so the standard for lightning protection systems is what we use in all of our design, and that's basically what we're going to be referencing today. So here's the basic outline of what we're going to cover. What is lightning protection? It's kind of a regurgitation of the previous slide. Basic principles, applicable standards, lightning protection design basics, what is the zone of protection, inspections and maintenance programs of these systems, and what Harger engineering support we can provide. I hope you got that audio there of lightning strike. But what is lightning? In the simplest form, it's a giant electrical spark, 30 to 50 million volts, 18,000 amps of current, and actually it's been measured that it can be 10 times that amount. Lightning is 5 times hotter than the surface of the sun, approximately 50,000 degrees Fahrenheit. So obviously with this type of destructive force, we want to be able to protect facilities and make sure that none of this mitigating damage happens to anything we want to protect. Damage from lightning, if you don't have proper systems, you can take direct strikes, which are going to create fires, cause destruction to the facility. Here we have an example of a residential application. Most of what we run into is more on the industrial commercial side of things, but here's an example of a direct strike, and it can have a catastrophic damage to your facility. It's also direct strikes that can damage electronic equipment. So just as important as the physical structure, we want to make sure in industrial applications, manufacturing applications, that we're protecting the electrical equipment, the drives, PLCs, starters, anything that can cause a lot of downtime, which can be very expensive. Also, there's an issue with indirect strikes. So indirect strikes from power lines, communication lines, they can also cause damage to the electronic equipment within a facility. So what exactly is lightning protection? It's a complete system of strike termination devices, the conductors, which is typically physical cables that run on the outside of a building, but also can include the structural steel of a facility, the grounding electrodes, most commonly used are ground rods, interconnecting conductors, surge protective devices, and whatever connectors and fittings are required to bond and complete the system. What is not lightning protection? Well, from NFPA 780, we go off of the Franklin rod design. There are other designs out there called early streamer emission systems. They can be radioactive. They're pulse voltage. They have controlled leader systems. These systems tend to, for lack of a better terminology, attract a lightning strike, and then it's going to take it supposedly safely to ground. You also have some materials that are considered lightning prevention, dissipation array systems, charge transfer systems. Neither of these strategies have been accepted by the U.S. standards body. So we're not trying to attract or repel lightning. What we're saying in a Franklin rod system is that if lightning does strike a facility, we're going to design that system that it's going to take that strike safely to ground, and there's not going to be any damage to the structure or to the electronic equipment. These systems that we were just talking about, they're not recognized by NFPA, IEEE, IEC, or the U.S. military. So specifying these systems may not be a defendable design. So it's just something to think about when you're creating specifications for these systems. Basic principles of lightning protection. We want to intercept the lightning discharge. We want to safely conduct the lightning current to Earth. We want to minimize any effects of the current. We want to make sure we're properly bonding and routing of the down conductors. And we want to protect incoming power and communication circuits with surge protection. Applicable standards, NFPA 780, UL 96, 96A, you can see the listing of them. The most common two that are used and most installers and engineers are familiar with are NFPA 780 and UL 96. Again, the standard for the installation of these systems, NFPA 780, and it's ANSI accredited. Same organization that's responsible for the National Electric Code. It's the most active standard, and they are very good at updating and making sure that they are up to date with any technological changes out in the industry. UL 96 provides the manufacturing requirements for the lightning protection components. So for a system to be valid, the proper bonding connectors, conductors, all have to be listed for the purpose. UL 96A, it's not ANSI accredited. It conflicts on certain topics, certain installation practices with 780, and it's only sporadically updated. So again, this is why we prefer NFPA 780. So certification. So these systems are designed and they have to be inspected. Well, they should be inspected for the owner to make sure that UL listed parts and that the installation contractor is installing this properly and it's going to work and be a safe system. There's two entities that have inspection arms, third-party inspectors that can inspect lightning protection. The electrical inspector does not have jurisdiction over lightning protection. So UL has an arm that does inspections, and they have what they call master labels and letters of findings. And then there's another group, LPI, which also has what's called a master installation certificate inspection, and then what they call limited scope inspection. We'll go over that a little bit more on upcoming slides. So a lightning protection system that is installed in accordance with a nationally recognized standard, like NFPA 780, is eligible for a UL listing certificate known as a master label. So when the building's completely protected, you have UL come out, they will inspect it, and then they will issue what they call a master label that's good for 5 years. And these are listed on UL's website. So this is verification for the owner to know that the system has been installed properly using the appropriate parts and that it's good for 5 years. After that, it has to be re-inspected. They also have what they call the letters of findings, and this is issued for structures that are a partial structure is the best example of this. So if there's a facility that has an addition or a partial protected structure, they issue what they call letters of findings. And what this is basically saying is that addition might be covered, but the entire structure is not. The letter of finding does not have an expiration, and they are not found on UL's website. LPI has a division, LPI IP, that does the inspections, and they utilize Intertech to complete these inspections. The LPI Master Installation Certificate is what they call their document, and it is only good for 3 years. LPI offers a limited scope. Sorry about. I apologize for that interruption. LPI, like I said, is good for 3 years, and they also offer a limited scope inspection. And when we're talking about these 3 years or 5 years, that is if nothing on the rooftop has changed that may compromise the system. The best example of this is you may have a 5-year master label, and then if the facility goes and adds security cameras, that could void the system out. So if nothing on the rooftop has changed, the system's good for 5 years or 3 years. If there's something added that lightning could flash over to and compromise the system, then it needs to be properly bonded and corrected and then re-inspected. Lightning protection design basics. Again, we are reiterating the point that we use NFPA 780 for the basis of our standards and design. Strike termination devices. A strike termination device includes terminals. Air terminals is the common term that is used out in the field, but also mast, permanent metal parts of structures, or overhead ground wires can be used as strike termination devices. Combination of these strike devices shall be permitted. And what they're saying there is on part of the structure you could have an air terminal. On part of the structure you could be using the structural steel as your down conductor. So you may have different combinations of these products as part of the system. Metal parts of a structure that are exposed to direct lightning flashes and have a metal thickness of 3/16 or greater shall require only connection to the lightning protection system. So on a commercial facility, you're going to have air terminals on top of the structure around the perimeter, and then you're going to have down conductors that go down to the ground system. If you have a structure that's 3/16 of an inch or greater, it can be used as the down conductor. So if you think about like towers or structural steel, as long as they're bonded properly to the ground system, we use those as ground conductors in lieu of a ground conductor cable. Air terminals. The tip of an air terminal shall be not less than 10 inches above the object or area it is to protect. So basically, the perimeter of the rooftop, that air terminal has to be 10 inches above that surface. So it can be greater than that. You can use an 18-inch air terminal or 24-inch, but we want to keep that profile as low as possible. Aesthetically, that's not always the most pleasing, and from a cost standpoint, we want that to be as low as we can. Location of the devices or air terminals. Distance between the strike termination devices needs to be 24 inches from the corner, or if you have a gently sloping rooftop, the same principle applies. We want to be within 2 feet of that corner of that ridge top. Also, they need to be on the ridges of the pitched roofs or on a flat perimeter. We want to make sure we have a strike termination device every 20 feet. So no more than 20 feet, that's where you have to place these. One of the things that we do from a manufacturing standpoint is we mark the conductor every 3 feet, because the bases that have to be glued down to the structure have to be spaced out no more than 36 inches apart. So we try to make that a little bit easier on the installer by providing markings on the conductor itself. But the strike termination devices have to be at least no more than 20 feet apart. So if you have a flat or a gently sloping roof, in addition to the strike termination devices on the perimeter of the facility, in the center of or going across the structure, you have to have an additional termination device every 50 feet. So you can see that here. These are all spaced 20 feet apart, and then the center every 50 feet. Down conductor placement. So on every system, you have to have at least 2 down conductors. So you have 2 pathways for the energy of the strike to dissipate. Structures exceeding 250 feet of perimeter, they'll have a down conductor every 100 feet on average. And down here, they kind of give an example. They show where these down conductors are placed in 4 different places. The distance between 1 and 2 is 110 feet, 2 and 3 is 95. Location 3 and 4, 95. So the total perimeter is 385 feet. So in the design, 4 conductors, down conductors are needed. They're tied off to the ground electrode and then ultimately tied off to the ground system. Grounding electrodes. Each down conductor shall terminate at a grounding electrode. Most of the time, you're talking about a ground rod dedicated to the lightning protection system. Ground electrodes, the down conductor shall be attached permanently to the grounding system by bolting, brazing, welding, or high compression connectors listed for the purpose, and the clamps suitable for direct burial. So the ground rods themselves need to be copper-clad steel, solid copper, or stainless. Can't use galvanized rods for these applications. Structural metallic systems. So as I mentioned earlier, the structural steel can actually be utilized as a down conductor. So for bonding the perimeter, the top of the structure to the structural steel, then at the bottom we're going to bond to it to go to our grounding electrode. We have to make sure that that connection point is clean down to the base metal. The bonding plate has to be 8 inches square, and again, we can either weld or braze that connection. Zone of protection. So what the zone of protection is a 150-foot sphere that we're going to roll up to the strike termination device, and then anything underneath of that or outside of that is covered under the zone of protection. And that doesn't make a lot of sense, but I have a couple of slides that'll make sense to you when you see them. So there's the rolling sphere, and this is there's a calculation to this of what we actually need to protect or bond and what we don't. So this is probably a little bit better picture. So here's our ball that's 150 foot in radius, a sphere. Here's the building that we're trying to protect, and we have a strike termination within 24 inches of the corner of this structure. We roll this ball up to it theoretically, and everything in this area right here is what's considered the zone of protection. So if we have outbuilding structures that fall within the zone of protection, they won't need to have strike termination devices or anything bonded. They're protected by the air terminals and the LP system, which is on the rooftop. So again, here's this sphere rolled up tangent with the earth connected to an air terminal. Theoretically, this lower structure may be in the zone of protection and does not have to be protected. Here's a better picture. So again, visually, this ball, the sphere is rolled up to the strike termination on the building that we can't see on this slide. So all this area in through here is in the zone of protection. So what that means is this canopy, this lower building, does not have to have strike termination devices, and anything, air handlers, anything that would be on top of this structure would not have to be protected. This is just another picture of it. So we're saying this lower rooftop canopy, we don't have to protect that. It would not be part of the system design. So inspection and maintenance programs, one of the things we see, a lot of lightning protection systems have been installed in facilities over the years, but they're not maintained very well. A lot of times they're dilapidated. There's capital expenditures for the original installation, but then these systems are not maintained. NFPA 780 recommends guidelines for maintenance in LP systems to be provided to the owner at the completion of the installation, and this is part of what we do. When these systems are designed, say, here's the operations and inspection manual. Should inspect these systems every year, and then they have to be re-inspected by a third party, UL or LPI, either every 3 years or 5 years. So when we say inspections, these are all mechanical connections on the rooftop for the most part. We want to make sure there's visual inspections that take place on all exposed components. We want to do continuity tests for the concealed portion of the LP system. We want to do ground resistance testing. And any new additions to the building need to have lightning protection added to them. So sometimes you'll have a facility that has lightning protection, they add to it, they're expanding, and then they don't have the rest of the facility updated and add LP systems to that. Why are the inspections important? Well, you get damage to these, these are exposed outdoors up on top of the roof. They get damaged by the weather. They sometimes get damaged by contractors. Somebody might be repairing an HVAC or air handler system, and everything does not get reattached the way it should be. So inspections are very important to these systems. Also, you can run into corrosion, so it's important to use the proper antioxidants to these mechanical connections so that they last longer and have to be replaced less often. Proper records of each inspection should be maintained, and necessary changes or repairs of the LP system should be completed immediately. So when these systems are first installed, it's highly recommended that, and we somewhat help with this process with our installing partners to make sure there's photo documentation from the original installation, and this makes it much easier to do the inspection process, and you can do the inspection process much quicker. The goal behind all this is make sure that the system's valid, that if it does take a strike, it's going to work properly, we're not going to have any issues. Proper maintenance of the facility is important for a successful recertification. So we mentioned earlier 5 years or 3 years, depending on what entity is doing the inspection. So proper maintenance makes that go much quicker, and it's much more cost effective. It's not as expensive to go through the recertification process. But as I said earlier, a lot of times these systems are not maintained. So I know you're going to forward questions to this. This is kind of the educational part of it. I did want to take a couple of minutes to go over some of the things that Harger can help you with also. We have a fully staffed engineer department that creates these designs. We offer specification support, and we do complementary design services for engineering firms that wish to partner with us. And when I say complementary and partner with us, that means if we would be sole specified and provide those designs free of charge. We produce thousands and thousands of details. If you have some specific application that you need help with, we'd be more than happy to do that. We can also help if you're just trying to put together some budgetary numbers and try to figure out on a specific structure, is this a $20,000 project of lightning protection, or is this $200,000 worth of lightning protection? This might be a little bit hard to see, but one of the things that we provide as part of this process on our drawings, the shop drawings that we provide for the installers, is we go to the specific detail of showing bend radius of conductors, the specific part numbers of where they go. They're extremely detailed, and it's not typical within the industry. We kind of go above and beyond to make sure that everything goes smoothly on the installation side, and that the system will be approved and will be a viable working system that'll last until the next reinspection. We've been doing this for over 60 years. The company originally started as a lightning protection installer. We've morphed or expanded. We're now a manufacturer of lightning protection parts and grounding materials, and our products are made in the USA, and anything we can do to help support your lightning protection specifications and design, we'd be more than happy to help you. And that concludes the presentation. Thank you all for taking the time out of your day to join in, and hopefully we can help you in the future with your LP design needs. Thank you.